Hi guys, welcome to my YouTube channel. In this video, I am going to discuss about the complete roadmap to become an embedded engineer. And why I am making this video is, when I thought to become an embedded engineer, there is no complete roadmap to become an embedded engineer. As a student, I have struggled a lot to find the complete roadmap. So, in this video, I am going to frame the complete roadmap to become an embedded engineer from scratch. This is especially for the students. I have created the 10 phases from phase 1 to phase 10. Stay tuned. Last two phases are very important to become an embedded engineer. I'm going to share all the free resources like videos, articles and books. Everything will be free. Before going into the video, please like and subscribe. It helped me a lot to do more. Now we'll discuss what are embedded systems. Embedded systems are the specific electronic devices which will do the specific task. For example, we'll take as a AC remote. AC remote is an embedded system. This AC remote is designed for only the specific task to increase or decrease the temperature of the AC. Like this, if we design an electronic device for a specific task, then we call it as embedded systems. And embedded system is the combination of hardware and software. The VLSI engineer make the chip and give it to us, and the embedded engineer is the one who write the code for it and give the functionality to that. Now we'll step into the 10 phases to become an embedded engineer. And the phase 1 is basic electronics. Basic electronics includes transistors, resistors, diodes, digital circuits and digital design, computer architecture, like this. As these are all the part of our academics. So learning in our academics is enough to become an embedded engineer. We have to strong in these basics. Let's step into the phase 2. Phase 2 is all about coding and programming. In embedded system, we majorly use C and C++ to program an embedded device. The reason of using C and C++ other than Java and Python is the C and C++ interact with the hardware very fast and the result will be within the time constraints. So we use C and C++ rather than Java and Python. In this C and C++, you need to master the topics like arrays, pointers and few data structures. Once you completed your programming, you start building few projects so that you can practically apply your learnings into that. Let's step into the phase 3. Phase 3 is completely about microcontrollers. In this phase, you have to know about the differences between the microprocessor and microcontroller. The thing which we use in our general computer is microprocessor, and the thing which we use in the embedded devices is microcontroller. In this microcontroller phase, you need to know about all GPIO pins, ADC, DAC, timers, clock and every pin on the microcontroller. And you have to know about the architecture of the microcontroller. For this, you can download a datasheet from the online so that you can know everything about microcontroller. In this phase, for the beginners, as a student, you can know about Arduino. Arduino is the majorly used microcontroller for the beginners, as it is the open source and it is easy to code. And in this phase, you need to apply your programming learnings. I'll say how. Now write a small C program to blink an LED or to start a motor or to read input from the sensors. And build a small project. This is fine in this phase. Let's step into the phase 4. Communication protocols. What are you thinking that how embedded devices talk to each other and transfer data? Yes, we use communication protocols to transfer data between two embedded devices and to make interaction between them. And in embedded systems, as an embedded engineer, you have to know about I2C, SPI, UART, CAN. These are the 4 major protocols which every embedded engineer should know. And apart from this, there are many protocols like Wi-Fi, Zigbee, Bluetooth. There are many. As an embedded engineer, these 4 are mandatory. You have to know about them. After knowing about the communication protocols, you build a small project as use your programming skills and microcontroller skills and apply them. Using UART, you transfer data to the other device and build a small project. Now let us step into the phase 5, RTOS. We all heard about OS. And what is this RTOS? RTOS is nothing but real-time operating system. In general purpose computers, we use OS. And in embedded devices, we use RTOS. What's the difference between them? The major difference between the OS and RTOS is the time constraint. For example, you are running a task in your computer. For some reasons, the task may got extended than the time it should complete. Here, the system performance will be degraded. Nothing else will be happen. The system will work fine, but only the performance will get degraded. But the same thing when you come to embedded systems, everything should be time constraint. The scheduled task should complete within the time frame. So this RTOS plays an important role in our embedded system. I'll say you an example. For example, in cars, whenever the crash is detected, within the few milliseconds, the airbag should open. If the airbags not open, the system will get failed. If airbags won't open within the time, there may be a loss of life. So, to complete the airbag opening task within the time frame, we use RTOS. RTOS plays the main role in the scheduling tasks and to complete within the time frame. In this RTOS, you need to know about scheduling, multitasking, mutex, everything. Stay tuned. I'll provide all these resources at the end. And now we'll step into the phase 6, debugging. Debugging is nothing but going step by step into your code and find where the problem is. As an embedded engineer, you have to know about debugging. If any problem occurs, you need to know where the problem occurred in your code. For that, we'll use debugging. The majorly used debuggers in embedded systems are JTAG and SWD debuggers. As a student, knowing the basic knowledge about the debuggers and how we'll debug is more than enough to start. Now we'll get into the phase 7, build systems. When you are in programming phase, you write a program and just click on the run button to compile the program. But what if the project contains the multiple files in different folders? To build all this, we need a build system. In embedded system, mostly we use CMake. This CMake will compile and link all the files and create a binary file. This build system will create the .elf, .bin, .hex files which we're gonna flash into our embedded systems. Let's step into the phase 8, version control systems. Some of the version control systems are Git and SVN. The majorly used version control system is Git. Why we use version control systems? The different developers will work on the same project. So to track the changes, commit, merge and revert the changes, we use these version control systems. As an embedded software engineer, knowing about version control systems is very important because you need to push your code into Git and you need to track your project and you need to track your code. These are about version control system. As I said initially, last two phases are very important to become an embedded engineer. Now we'll step into the phase 9, building the projects. Knowing all theoretical concepts is not enough to become an embedded engineer. The things which you have learned, you need to apply on it and you need to make the projects. Build small projects and build your GitHub profile. Building projects will teach you many things which you won't learn in your theoretical sessions. So my suggestion to all the students is to start building projects once you have done with your theoretical part. And finally, we are at last phase. And we are reached the final of the video. This is the phase 10, soft skills. As a student, it is very important to develop the soft skills like communication, analytical skills, problem solving. Not only as an embedded system, if you want to go into any other field also, these skills are very important. And once you got the basement with your soft skills, start building connections. Use your LinkedIn profile and search for an embedded engineer. You can see what are all the skills they have and start connecting with them and interact and ask for the guidance and build your connections before you enter into the industry. It will be very helpful for your future. And we have reached the end. Before ending the video, I'll say the few domains. After you have learned all the skills in all the phases, there will be specific domains in embedded systems. For example, the domains like automotive, agriculture, healthcare, aerospace, consumer electronics, robotics, like this, there are different domains. Choose your interest and start building your skill set according to that industry. And finally, as I said, I'll provide you the free resources to become an embedded engineer. In my description, I'll attach the 10 phases roadmap and also a GitHub link in which you can find all videos, articles, books, all the resources and all the steps to become an embedded engineer. And this will help you a lot to become an embedded engineer. And all the best for your future. And please try to share this video to your friends who are interested in embedded systems, all ECA and EEE friends. And don't forget to comment so that I can get the feedback and I can make many more videos which are better than the previous. Thank you, signing off, and don't forget to subscribe.